screen. Okay, I share the screen. Okay, share the screen. Now let me go there. So I have updated the handout. This handout, there is a lot of links of the problems. Okay. Try to solve as many problems as from these links. Try to understand these things, then your exam will be easy. Next Thursday, there will not be any physical class, but during the class time, I will maintain office hour. You understand, right? Online, you will find me. On the same link, I will join. This link I will join, and you can jump in. And if you have a set of questions or any question, you can ask me. Next Thursday, I will open the exam. Understand? It will be open for 72 hours or maybe 96 hours. Okay. So it should be all Friday, Saturday, Sunday, or maybe also Monday. I will check. But at least up until Sunday, 11:59 p.m. Okay. With that being said, now let me solve a problem. Okay, so now I want to solve a problem and write a problem and want to see how many of you can solve this problem. Okay, so let me write it. A complex radar system has 3 units which can a complex radar system has 3 units which can independently detect missiles with success probability for them are 0.95, 0.85, and 0.75 respectively. You understand, right? So when there is a radar system, some people will monitor them. Some people will operate them, right? Okay. So first layer, second layer, third layer, something like that. So they have a success rate of shooting down the missile at 0.95, 0.85, and 0.75. Okay. Among this in this sentence, if I ask you to find one word that will give you the hints, the clue, the way to solve this, which word is that one? Can any one of you tell me? By reading this one sentence, I want you to find one word that will give you clue, the hints. You understand? Quite good. You understand? What's the word? Independently. Understand? Independently. So independently detect. Okay. Suppose the opponent opponent launch a missile. Find the probability that number one, exactly one unit detect the missile. Exactly one unit detect the missile. I don't know. There are three, right? A missile come, exactly one unit can detect it. Exactly one. So one detect, other two is the, you understand, A, B, C, three unit, right? If A can detect, B and C cannot detect. If B can detect, A and C cannot detect. If C can detect, A and B cannot detect. Exactly one unit can detect the missile. Okay. Number two, at least one unit can detect. Number three, all three units can detect. None of the three unit none of the three unit can detect. Okay. Clear, right? I want to give a few minutes to you, and I have to check how you can think to solve this problem. Let's see. I want to give you, maybe it's now 1:15. I want to give you 10 minutes. And during these 10 minutes, I ask you, do not speak, do not ask me any question. I want to see among six of you who can solve completely or partially of this problem. You understand, right? I want to give you 10 minutes. Please, at 10:26, I will start solving this problem. Sure. And sorry for my very bad handwriting. No, but for some reason, handwriting is not good in this pad. But I can read it for you if you want, okay? No, you cannot actually do the solve problem. Done. So one more minute. Okay, this is 16. So let me solve this problem. From there, you can try. Okay, check whether exactly 1 unit. Okay, exactly 1 unit. So exactly 1 unit means probability of when first unit gets success. Okay, second unit B do not get success and C do not get success, right? Then probability of A cannot detect, B can detect, and C cannot detect. Third, A cannot detect, B cannot detect, but C can detect, right? You understand these things? So now you know this is the definition of independence, right? Probability of A and B. If this is, then you can write as probability of A times probability of B. This is the definition of independence, right? Now, if in if if in a contingency table, if two events are independent, remaining all of the other events are also independent. Understand, right? So as A and B are independent, so that means A and B complementary, they are also independent. So this is equal to probability of A times probability of B complementary. Clear? Do you understand these things? In a contingency table or in a event space. Event space means collection of all events. In a event space, if two events are independent, all other combinations of events are also independent. Okay. So now, if this is true, I can write it like this way: probability of A times probability of B complement times probability of C complement. Now, probability of A complement, probability of B, and probability of C complement, probability of C complement. And then probability of A complement times probability of B complement times probability of C. Okay? Exactly. Exactly. So probability of A equal to 0.95, right? Probability of B equal to 0.15. Probability of C equal to 0.25, right? Okay, now that one is probability of 0.05 and probability of 85 and probability of 0.25, right? And then probability of 0.05, probability of 0.15 and probability of 0.75. Do you agree or not? Are you okay? Please not agreeing. How about you? How about you? So are you saying 0.95, 0.85, and 0.75 that was given, right? Yeah. So probability of 95 is to detect the missile and probability of 1 minus 0.95 is to not detect the missile. Failure to detect the missile. 1 minus 0.95 is 5. No, 0.05. 0.05. I've never written 0.15. It's just the order. Okay, now B equal to what? B equal to 0.85, right? And then B complement equal to what? 0.15. So your question is why 0.15 in here, right? 0.15 is coming corresponding to B complement. B equal to what? 0.85. 1 minus 0.85 equal to 0.15. Now you understand? Are you okay? No. Okay. Where I can explain? Okay. Probability of detecting the missile by unit A is 0.95, right? It is given. And probability of not detecting the missile by unit A is 1 minus 0.95, which is equal to 0.05. Let me write it in here. So take a look at that. This is what I want to explain to you. Probability of detecting by the unit A for an incoming missile is 0.95. Okay? Probability of not detecting the missile by the unit A equal to 1 minus 0.95, which is equal to 0.05. Do you agree with that? Similarly, probability of B equal to 0.85 and probability of not B equal to 0.15. Probability of detecting missile by unit C equal to 0.75. Probability of not detecting the missile by unit C equal to 1 minus 0.75, which is equal to 0.25. So this is the combinations I have done in here. Understand now? Now understand? Clear, right? Clear, right? Are you okay now? You understand now? How about you? Good, right? What is that value? 0.051875 of approximately 5%. Exactly 1 unit detect the missile. Exactly 1 unit. Now, I want to put a hold for the at least 1 unit for the later, but all 3 units can detect the missile, which is equal to number 3. This is the number 3. All 3 units can detect the missile A, B, C, which is equal to probability of A times probability of B times probability of C. Right? Right, all 3 units, which is equal to 0.95 times 0.85 times 0.75. Okay, clear? All 3 units. This is number 3. Number 2, I will come later. None of the units can detect, which is equal to no, none of this is A cannot detect, B cannot detect, C cannot detect, which is equal to probability of A cannot detect, probability of B cannot detect, and probability of C cannot detect. Okay, which is equal to 0.05 and 0.15 times 0.25. Right? Third question, which could be answered. So this is the all unit can detect, right? All unit can detect. And then none can detect. No, this is not the second question one. This is the one. Yeah. At least one minus at least and that one. Yeah. So that is why I want to do this. This is none can detect, right? None can detect. Okay. And then at least one can detect, right? So at least one can detect. I want to solve it in multiple ways. Yeah, so see, at least one can detect. So number 2 now. at least one can detect. At least one can detect. I want to solve this problem in 2 ways, or maybe 3 ways, something like that, 3 ways. Okay. First one, take a look. If I want to do these things in this format, this is the unit A, this is the unit B, this is B, this is A, and this is C. Okay, this is C. And this area is a common area for all of them. This is the part which could be detected by all A, B, and C, right? This red area is shared by A, B, and C, right? So that means all three can detect, right? Now come in here. If I want to do these things, so this is the all three and remaining part. That means none of this is in here. None can detect would be in there. None can, this is the area where none of the three can detect, right? Do you agree with that? Outside of this area is none can be detected, right? Clear, right? Agree? Okay. Now, none can detected is obtained by this, right? So, if you want to do, none can be done by these things. This is the none. This is the none. This is the none. Okay. And then which I can do 1 minus 9, which is equal to 0.05 times 0.15 times 0.25. Do you agree with that? So this part is none, right? So that is why I put the green color. So let me go and erase this thing so that you can understand. Let me go there, take this, and I just want to delete these things. Go here and come here, 1 minus this. So green part is none. 1 minus this will give you at least. On the other hand, suppose I want to find its second approach. This is the approach 1. This is the approach 1. This is the approach 1. Second approach, I want to find at least one unit which could be done by probability of A union probability of B union probability of C. So that means A union B union C, which could be written as probability of A, probability of B plus probability of C minus. Okay, take a look at that. Now I ask you to take a look at the board. If I write here probability of A, then this part is coming in here, this part is coming in here, this part is coming in here. So that means these three part is considered in here, right? If I write here probability of B, this part is this part, that part. So these three part is shared by the other two. Okay. Now, if I write here probability of C, then this part, and that part. So this part is shared by at least two others. So now I have to subtract probability of A and B minus probability of B and C minus probability of A and C. So A and B equal to what? A and B equal to this part. Okay. So I subtracted that part. And then probability of B and C. B and C equal to this part. I subtracted that one. Probability of A and C, which is equal to this part. This part. So I subtracted this part. So that means I subtracted this part. Now I have to add this one in here. So what is happening? I consider in this one, and then I am adding that one. This one I am adding. Okay. This is what I am going to mention because they are coming two times. So I am adding this probability of A, B, and C. Okay. Now see, I know probability of A equal to what? Probability A equal to 0.95. Then probability equal to 0.85 plus probability of 0.75. First approach is easier, but this is the another approach which you can visualize and think. That is why I'm giving the two approaches. The second one is A and B. A and B equal to 0.95 times 0.85. Then 0.85 times 0.75. Then 0.95 times 0.75. And then plus 0.95 times 0.85 times 0.75. Clear? So now this do this computation and tell me whether these two results are same or not. Compute these things and compute these things. Tell me the results whether they are same or not. They are same, right? In both cases, right? So now if I ask you to detect the missile by exactly 2 units, how can you do that? Exactly 2 units, you can do this. Probability of A, B can detect, C cannot detect. Probability of A cannot detect, B and C can detect. And probability of A, B cannot detect, C detect. This is the exactly 2 unit can detect, right? Exactly 2 units. Are you understanding? Yes. Okay, now let me take you to the some problems in here, maybe in here. Let us solve one or two problems from there. Or maybe let us solve some problems in there. Where is my 1, 2, 3, 4, 5. Okay, let us solve one problem from each of these, okay? So what is problem in here? A coin is tossed and a die is rolled simultaneously. Okay. Draw a table to show all possible pairs of outcomes. From your table, calculate the probability of getting a head and two, and state if these events are independent. A head and two. A head and two could be obtained this way. A head and two, this could be obtained like this way. Now we want to find this probability, and then we want to find the probability of head and then probability of two, and then we want to multiply them to check whether they are independent or not. Okay. So in the cells of the table, we list the possible combination of the outcome. There are 12 outcomes in total. To find the probability of getting it head and two, we find the row with H and column with 2 and read across H and down 2. The cell where they meet shows is H2. So this is equal to 1 over 12. So the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Out of 12 outcome, only one outcome has head and two. That is why it is 1 over 12. Okay. Now probability of head and 12. Probability of head equal to probability of 2 equal to 12 over probability of 2 equal to 2 over 12. Why probability of 2 equal to 2 over 12? Because this is the only two cases where there are two twos appears, right? So out of how many? Out of 12. Out of 12, 2. So that is why it is equal to 1 over 6. How many H appear? There are 12 H, 6 H appear out of 12. So 1 over 6. So if you multiply them, then you will get here half times 1 over 6 equal to 1 over 12. So that means 1 over 12 multiplication is equal to the joint probability. Individual probability, marginal probability multiplication is equal to the individual probability. So this is the definition. Why I cannot write it in here? So definition of independent is two events are said to be independent if probability of A and B equal to probability of A times probability of B. So here I got 1 over 12, and here I got 1 over 2 and 1 over 6. So that is why they are independent. Clear, right? We solve one problem from there. Please, there are a lot of problems has been given there with the solutions. I did not follow any specific book in here. I rather focus on giving concise material or 10, 12 pages documents and then sample problems so that you can succeed. Yes. Your exam, you said each question will get 5 minutes. 5 minutes, 20 questions there will be. 5 minutes. 5 minutes. Okay. And this is a very difficult exam. If you do not follow the lecture, the handout that I gave, and do not watch my videos and do not solve these problems, then you will be in trouble. But if you solve this problem, then everything will be easy. This is the very basic class. If you become very good in this, then you will get interest to develop, to go to the next one, to go to the next one, go to the next one. Okay. So now the table shows the results of testing two different treatments on 240 fruit trees which have a disease causing the trees to die. Treatment A involves the careful removal of infected branches, and treatment B involves removing infected branches as well as spraying the trees with antibiotics. Okay, so now fill the missing values. So this plus that equal to 120. So this will be my 120. Let me see, I cannot write it here. 120, and this will be equal to, this is subtracted from that, so it is equal to 100. This is subtracted from that, this is equal to 20. And then if you add this and that, which is equal to 100 plus 20 equal to 120 is in here. This is 120 in here, so it should be 240 in there. So this is what you have done with the fillings of the table. What is the probability a tree received treatment B? Treatment B, a tree received treatment B. So this is divided by that. This is equal to, here is 20. Here is 100. So 120 divided by 240. So this is the answer of that. Clear, right? What is the probability that a tree will live beyond 4 years? The tree lives more than 4 years. So equal to 150 divided by 240. Okay. What is the probability that a tree is given treatment B and lives beyond 4 years? So that means this is a conditional probability. What is the probability that a tree is given treatment B? What is the probability that a tree is given treatment B and lives beyond 4 years, which is equal to this? Treatment B and live beyond 4 years, which is equal to this 100 divided by 240. Joint probability of the trees that are given treatment B. What is the probability that a tree live beyond given treatment B? So that is a conditional probability. Let me write the number 5. Of the trees that are given treatment B, what is the probability that a tree live beyond 4 years? So live beyond 4 years, 4 years, and treatment was given B. So which you can do probability of 4 years and B divided by given treatment B, which could be obtained by B equal to what? B equal to, here is 100 plus 20, 120 divided by 240, and here 240, 4 years and B, 4 years and B, which is equal to this 100. So you have 100 over 120. This is the answer. That is a conditional probability. Okay. How do you know a problem is a conditional probability problem? You understand? So the how do you know a problem is a conditional probability problem? That means it should be written like the way I have written. Something is given that come after the vertical line. Okay. It is written, find the conditional probability that what is the value of x when y equal to 2. So that means y will go there, y equal to 2, and then x is in here. Either what conditional probability would be in the question, or in the question given that what is there. Find the probability that a selected person is a player given that he is a minor. So minor will come later and player will come first. Between the vertical line, this vertical line. Okay. What is given is coming after the vertical line. What is asked to find is coming before the vertical line. This vertical line means given. Okay. A tree given treatment or a tree given treatment B living beyond 4 years, independent event, justify your answer. So it is a checking whether the joint probability is equal to their individual probability. The sixth one is asking you find A and B and check whether this is equal to probability of A times probability of B. Okay. Okay, let me solve another problem in here. Okay. Okay, good question. by reading the question, if I give the table, then it is super easy, right? But I can write the table problem in some words. From there, you can formulate the table. Once you formulate the table, rest of the problem is just like this, right? I can say that in a community, there are 300 people. Among them, 200 is minor and 100 is player. So 200 is minor, and then 200 is subtracted from 300. So that means 100 is adult, right? So you find the minor and adult, and 100 is player, 100 is subtracted from 300. So that means 200 is non-player.
You're not going to give no like very big examples for maybe a table of field.
Yeah, maybe for you, I
That's
just give you one customized, very big, crazy table. It will be maybe 2 by 2. If I give the results in a continuously in a word format, it should be 2 by 2.
So for the tables that we have to make on the exam, would it matter the order, like which side you?
No. You can put adult first, minor second. So he's saying when you create a table, is that does the order matter? Order doesn't matter, but frequency should be the same. So suppose she created a table like this way. She created adult and then minor, and then she put here non-player and player, right? But you created a table minor and adult, and then you put it a player and non-player. Okay, but if you create a table minor and player and adult and non-player, that is a great mistake. You understand what I said? You understand what I said? If you put minor and player, so that means you are not matching that. In that way, you cannot construct the table.
Was actually when it mattered, like the what we're doing, it mattered, which was on which side. Like,
No, it should not be matter. In epidemiology, it is matter.
I think it was for.
Show me, come to my office with the example, then I want to explore it and I just want to learn why it's matter. You understand? He said that no, in the epidemiology, players should be in the column, and then people should be minor and adults should be in the row. He said that that matters. So come to my office and show me an example so that I want to learn something.
Actually have it right.
Okay, you have it?
Yeah, so we're trying to construct a table on like for academic performance and then we just had to do like the GPA and flow thing.
Okay, 3.5.
Right, so it was like if you did like GPA of
So what will happen if GP 3.5 if you put it in there?
no, it was just like the way that we were constructing this table, like
And so my question is GP you put it in here, iPhone uses in there. What will be the norm?
I can show you what I'm using.
I think because this is like just where you're supposed to put like this is the disease and this is the exposure. That's how
That's the exposure, that's the outcome.
right. So like this is whether people have a condition and this is whether people
The
are
result.
exposed to what is believed to cause that condition. So I think that's just what it means like in,
I think it's the same
I think
thing
it's the same.
so. I think
like you
it's
calculate it the same, but like in order of reading it, like if you're an epidemiologist and you're looking at something and that's just how it should be structured. But I think you could calculate the same.
Yeah,
Just in
calculation
terms-
is the same.
Right, just in terms of like analyzing it,
Oh.
it just may need to be structured that way, because that's. I think that's just what it was.
So that means you are saying outcome will be in the row and exposure will be in the column.
Yeah.
Okay. Could you,
And that doesn't matter.
that doesn't matter. Then this is the problem.
This.
Okay. Could you send me these things and that thing?
Absolutely.
So just take a picture and then send it to my email, okay? I want to take a look at the, but results would be the same, okay? Results would be the same. If there is something like the like treatment and outcome or exposure and outcome, that could be different. So that there should have a logic. So why they want to put outcome always like this way, okay? Okay, let us solve this problem and then we will move to the another type of problem. So a new treatment for influenza was tested on a number of patients to determine if it was better than a placebo. Do you know what is placebo is? So you both of you have a fever, okay? We want to give the real medicine to her and we want to give the placebo to you, but you do not know that I have given you the placebo. You know that you are eating the real medicine. You are taking the real medicine. This is what you know. But as I am a person, I want to check whether this specific flu, you will go away automatically or medicine needed. So 3 days later, both of you recovered. And then we said that, well, so this type of flu will be recovered automatically because she took the placebo and she took the real medicine, both of them recovered. So from next time, we should not recommend people to be. But this should not be done only for the two persons. This should be done on a people of a group of 200, 300 people. And then majority of the people with having placebo get rid of without any medication within 3 days, then we can end up with this. So this flu will go away. So now complete the table. If I want to complete the table, this plus that will make it, let me write it this way. Let me fill it like this way. Flu, no flu, placebo treatment. Flu, no flu, and this is placebo, and this is treatment. And this is the 228, 228, 240 to 360, 240, 312, 60, 240, 312. Okay. So then total equal to 8, 8, 2. And this is subtracted from that. So we will got here 28, just the 12 is in there. And then 60 subtracted from there, there is 200. Um, 2, and then this is equal to 4, this is equal to 6, this is equal to 2, then this is equal to 2, this is equal to 5, this is equal to 5. Okay. Okay. So now after doing these things, solve, complete the table, calculate the probability of patient receiving the treatment. Receiving the treatment, so that means 264 over 552. This is the number 1. Number 2 is telling you calculate the probability of patient having no flu after 3 days. No flu after 3 days. Number 2, no flu, that means 312 312 divided by 552. 3. Calculate calculate the probability of a patient receiving the treatment and having no flu. Treatment and having no flu. Treatment and having no flu, which is equal to 252 divided by 552. Number 4. Actually, number 5. Using a calculation, determine whether a patient receiving the treatment and having no flu after 3 days are dependent or independent events. Okay. So dependent on independent events, how can you check that? Like probability of A and B equal to probability of A times probability of B. This is the way. Okay. Yeah, right? So check this way. And after that, calculate the probability a person receiving treatment will have no flu after. Okay, could you tell me how can you solve this one? Calculate the probability that a patient receiving treatment will have no flu after 3 days. Calculate the probability that a patient receiving treatment will have no flu after 3 days. Which one is occurring first? So that is given, right? Conditional, right? So that should be done by using this way. Probability of like this. A patient receiving treatment. Receiving treatment. So that means receiving treatment and no flu. Okay. So how can you do that? You can do these things by using this. Probability of no flu intersection receiving treatment divided by probability of receiving treatment. So probability of receiving treatment equal to what? Receiving treatment equal to, so that should be 552. Here I want to put 552, 552, and then receiving treatment. Receiving treatment is 264, 264. Receiving treatment and no flu is 252, 252, 252. Okay, I think we have solved lot of problem involving contingency table, and you clearly understand how to use state theory. That means probability of A union B, probability of A complement, and what is independent, what is contingency table, and how to find conditional probability, at least at best, right? So let us move to the another part. Let us move to the another part now. Okay, so take a look at that. Just a simple problem like this. A jar contains 3 red, 4 blue, and 5 green marbles. So there are altogether 9 marbles. And if a marble is selected, what is the probability that it should be red? So there are 3 red out of 12. So that is why it is 3 over 12. Okay? This is the problem. From a deck of 52 cards, what is the probability of drawing an H or a king? What? So, so she has a problem with the card one. Other people, you are okay, right? So there are 4 kings.
I need to read about the course. I'm going to start learning how many aces, how many kings, how
Okay.
many.
It's 4 of each.
4 of each. There are 13 types, each of them is 4. Okay? Give me that.
I can find a deck of cards.
Give me the pen. Can I write in here? No, I need to take a fresh page. Can I take this one? Why you are so mean to? There is a one card, this is known as a heart. This is the one card known as the diamond. Diamond. And these two are red card. There is another card known as the clubs. This is known as the clubs. And this is known as the spade. This is known as the spade. And these are the black. This is the red card and this is the black card. So each of them has so this has a 2, 3, 4, 5, 6, 7, 8, 9, 10, joker, queen, kings, and 8. It also has 2, 3, 4, 5, 6, 7, 8, 9, 10, joker, queen, king, and 8. It also has 2, 3, 4, 5, 6, 7, 10, joker, queen, king, 8. It also has 2, 3, 4, 5, 6, 7, 8, 9, 10, joker, queen, king, 8. That's it. So, from a deck of cards, I want to pick a card. What is the probability that the selected card is red? So 26 over 52, right? 26 over 52, right? I want to draw a card. Selected card is an H. 4 over 52, right? H.
Oh, H.
Right? 4 over 52. I want to draw a card so that it could be heart. 13/52. Okay. So I want to draw a card which is ace or king. So there are 8, right? 4 ace, 4 king, 8. So 8/52. Remember, when I was interviewing for a job, so at the initial interview, so there are 3 rounds, 4 rounds of interview, especially if they interview for a position in Google, Facebook, something like with big companies. I interviewed them both. But for some reason, the academic life is more competent for me. I like academic life. Still, there are like many companies. I work as a consultant, CDC, Moderna Pharmaceuticals. I work there 6 months, 8 months, 1 year as a part-time consultant. But I enjoy working on this. So in those type of initial interview, they will ask you, I want to give you a simple problem of a card drawing. They will ask you this type of question if you do not know about the card. So that means you lack knowledge in one area. But that your friends and everyone, you are good in all other things. Why you will lack knowledge in one area? Understand? After coming to the United States, I learned all the time I am typing without looking at the keyboard. I learned coming in here. When I came here and was doing master degree, I saw that undergraduate students, American undergraduate students, they are typing without so I was typing like this way. Oh, I need to fix it. I asked him, how do you learn? So there are some typing game, just play those things. Then someone give me the link. 3-4 days I practice and I become that. And then I did not know R, Python, SAS. Actually, R, Python, SAS, I haven't heard when I was in back home in my country. After coming here. And then teacher was speaking mathematical statistics and there is some competition. I was so angry. I said that we are the statistics, we learn the theory, how they come into existence, why we need to learn the coding. So professor said that, see, you already learn a lot of math and statistics, right? Now, if you learn one language, then you do not need to go people to people, solve this, solve this. So just try to learn. And he just this simple word he said, I took it. I said that, well, let me learn R and then learn the other things gradually. Okay. So nowadays, to become best, you have to have a knowledge on multiple areas. If you do not do your job, someone else will do the job. If you are spending your time sitting idle, someone is working hard to get success. So the top positions, then you will go more and more competitive and they will open your CV. They will see how much knowledge you have. And then most top companies, they want to find a way to sort you out, not to incorporate you, understand? And especially those American citizens, you have to compete hard with the international talent. That is why America is superpower. Do you understand why America is superpower? International talent. They accommodate those things. And other nations, they do not have these things, psychology in their head, they do not have. So that is why Europe is not superpower. So they are not ready to accept international talent. America's forefather, they made it. So that is why top talent people across the world, they always want to come USA. If you go to the Harvard, MIT, Stanford, Georgia Tech, top university, you will see they are spending $200,000, $300,000, $400,000 for their education. They are talent in their country. On top of that, they have money. So they are coming in here. And also the people, if you are super talent, do not have money. International Math Olympiad, International Physics Olympiad, International this Olympiad. It is organized by them. When you get a gold medal in those competitions, American Stanford, MIT, Harvard, they give free scholarship. You understand? Those type of things should be done by the other countries. Japan, China, Bangladesh, India, Europe, they should adopt this American philosophy. That is why I step out a little bit because I want to give you the details of how many cards. So I have written now. Now, if I give a problem, I think you will be able to solve it. Okay. Come here, in a class of 20 students, 12 are girl. What is the probability that a randomly selecting is a boy? So 12 is girl and then 8 is boy. 8/20, right? A spinner with a number 1 to 5 is spun once. What is the probability of getting an odd number? So 1 to 5. 1 to 5, how many odd number? 3 odd number, right? So 3/5. Okay. A jar contains 10 balls, 3 red and 7 black. What is the probability of drawing a red ball on a single draw? So 3 over 10. These are easy problem. So there are some other problems in here. You can, okay, there is a 12 problem in here and with the answer is in there. Try to solve. I have provided maybe 6, 7 link. Try to solve all of these things. And this is the foundation of any statistics, mathematics. If you are very good with this foundation, then you will develop interest within yourselves to go to the next step, okay? Okay, let me go and try to do another one. Let me go this discrete probability join. Okay, so this type of probability I already solved. Let me see. Oh, it is already solved in here. We already solved this. We already solved this. So come in here. Here you go. Let me solve. Let me see. How is this one? Okay, you can take 5 minutes break. Then I will start again. Okay, take a 5 minutes break.
Excuse me. Excuse me, sir.
Mhm.
Please scroll down to the.
Which one?
Back the one you're writing on. The page you're writing on, the document.
Oh, that one. I think that one you will find in there. I don't know which one that. Oh, class document. This one. Here. This one.
Okay.
Okay, let me drink little water. Georgia Tech, I did my master degree in quantitative and computational finance. Oh, in what department? Biology. Yes, that.
Here, yes. He had the lab over there. He was in MG Paint lab.
Okay. Oh, committee in PhD section.
We're allowed to have like 1% from the outside.
Oh. Okay. So now let me go another one. Let me see which one we can. Let me see whether this will be easy one. Okay, let me try this one. In a lottery game, there are 2 winners for every 100 tickets sold on average. If a man buys 10 tickets, what is the probability that he is a winner? Without showing the answer, could you try to find this? In a lottery games, there are 2 winners for every 100 tickets sold on average. 2 winners for every on an average. So 0.02 is the probability of winning. If a man buys 10 tickets, what is the probability that he if a man buys 10 tickets, what is the probability that he is a winner? So see, out of 100, 2 winners on an average. But he bought just the 10. He did not buy the 100.
But he still has the 10%.
Does everyone?
In a lottery game, there are 2 winners for every 100 tickets sold on average. If a man buys 10 tickets, what is the probability that he is a winner? I haven't seen the answer, but let me think few minutes. So you are saying still that 2%? Yeah, 0.02. But he bought a 10 tickets. Probability of winning the probability of winning is 2 out of 100. 2. %? How? I did not see the answer. So this is equal to 10 and then this is equal to 2. Is this what you're saying? No. Yeah. Yeah.
We need at least one win, right? So it's probability for one win. That would equal to 1 minus P with no win. In that case, P without any wins would equal to 98, 3 of 10.
So 1 minus, this is the no win, right? 1 minus 2 over 100, which is equal to 98 over 100, right? This is the no win. 0.98 is probability of no win. So now, if you said he is a win, 10 ticket he is a win, 1 minus probability of no win. No.
Use one when it's 1 minus, no, the no win is not equal to 0.98. It's equal to 0.98, and we have the 10 as well. In the, what do we call
This is the no win 0.98, right? 0.98 no win. So he bought the, what is the probability he is a winner? They did not use any binomial distribution in here. Let me think.
So basically, he bought it 10 tickets, right? So each ticket has a probability of 0.98, right? Of not winning.
Non-win.
So he bought it 10, so we need to multiply it 10 times.
Yeah, so you put that to the power of 10.
And power of 10. Power
So-
of 10 tickets.
So first ticket, he win, which is equal to 0.02. Okay. And then, so are you seeing like 10 choose 1 and the probability of winning 1 and probability of non-winning, this is equal to 9. If it is, are they using binomial something like this? And then 10 choose
So basically,
2.
one,
So they are, so here is the thing. Ticket 1, ticket 2, ticket 3 and goes to ticket 10, right? So ticket 10 and then they multiply these things, right? So 3.98, they multiply 10 times. They okay, so first ticket no win, second ticket no win, third ticket no win, 10 ticket no win. Out of 10, there is no win. So 1 minus no win, that means win. So then why it is not like this way? 0.02 times 0.02 times 0.02. Why this is not? Winning in the first ticket, winning in the second ticket, winning in the third ticket. Why this is not the way? So if I want to do it, let me open the R. Where is my R? So I want to do it in this format. 0.02 times 10. Why it will not work? You are saying 1 minus 0.98 to the power 10, right? So if this is true, then why that would not be true? First one win.
That's the chance of every single ticket winning. And that's why the number is so small.
Okay, yeah.
That's the number of every single ticket winning, all 10 tickets. That's why the chances are very, very small.
So this is all 10 tickets
All 10 tickets winning.
winning.
Chance of all.
And here just not winning,
Yeah,
any of those.
tickets losing. And then we just 1 minus all 10 tickets losing.
Yeah, that makes sense.
That's why it's not working.
Okay, so here is the thing. Okay, that makes sense. You understand, right? No winning. 1 minus probability of no winning will give you the probability of winning. Okay, this is a very good explanation. I think this could be done. A bag of balloon consists of 47 white balloons, 5 yellow balloons, 10 black balloons. What is the approximate likelihood that a balloon chosen randomly from the bag will be black? So that is easy, right? 47, 57, and 62. So 10 over 62. Referring again to the MP3 player described in question 8, what is the probability that next two songs will be both B by brand B? Okay. Question number 8. Let us read the question number 8 first. A MP3 player is said to play songs at random from the 15 songs it contains in memory. Any song can be played at any time, even if it is repeated. So an MP3 player is said to play songs at random from the 15 songs it contains in memory. Any song can be played at any time, even if it is repeated. There are 5 songs by band A, 3 songs by band B, and 2 songs by band C, and 5 songs by band D. If the player is just played 2 songs in a row by, if the player just played 2 songs in a row by band D, what is the probability that next song will also be by band D? Yeah, 5 over 15. Because in a box, there are marbles, and I pick it and put it back, then even if I pick it again, then the number is the same, right? So the song already is in the disk. So there are the 15 songs, first and second song, then the same songs again can come. So there are 5 out of 15, so that means again it is 5 over 15.
So it's one in every property.
Yeah.
One in every.
What is the probability that next song will be by band D? So D has a 5 songs, right? And 5 by the band D. So 2 is already played by D. So, but again, that will come 5 over 15. So that means 1/3. That means 1 over 3. You understand this one, right? Or you want me to explain this? Okay. Yeah. So now go to the problem. Next one, referring again to the MP3 player described in question 8, what is the probability that next 2 songs will both be by band B? So same thing, band B has how many songs? 3. So that means 3 over 15. So this should be 3 over 15 times 3 over 15. Next 2 songs, 3 over 15 and times 3 over 15. So that means 1 over 20, 1 over 25, right? 1 over 25. Because as it is randomly coming, memory have all the songs. Okay. So that means there are 15 songs altogether. So the same band B will come with 3 over 15. That's good. So very good learning is the last problem. Okay. I was thinking like why it's not like this. So remember this type of problems. Okay. So let me spend few more minutes in here. In this case, if you find no winning of the ticket, then 1 minus no winning means winning. So that is why first ticket no winning 0.98, second ticket no winning 0.98, all 10 tickets no winning 0.98 to the power 10, and then 1 minus that equal to probability of winning. Okay, so here is the thing. A regular deck of cards has 52 cards. Assuming that you do not replace the card you had drawn before the next draw, what is the probability of drawing 3 H's in a row? So 4 over 52, 3 over 52 times 2 over 52, right? Okay, let me explain these things. So this is the box. In this box, those 52 cards are in there, and there are 4 H's, right? So I take the first one, which was 4 over 52, because 4 H's, first one will come this way, and I cannot replace it back. So next one is 3 over 51. The next one is 2 over 50. Next one, that is the answer. Clear, right? Okay, let me read the question. Looks like you little bit. So
It said only three.
okay, then we will stop at 50. A regular deck of cards has 52 cards. Assuming that you do not replace the card you had drawn before the next draw, what is the probability of drawing 3 H's in a row, which is equal to 4 over 52 times 3 over 51 times 2 over 50. And then as it is said 3, so we just need to get rid of that. Yeah. question 11, that means the one that I ticket question. What is the question? Let's go.
So, if the probability, so when you buy 100 tickets,
Hmm.
if the chance of winning is 2%.
Yes.
Why, if you buy less tickets, the chance grows? Like, why?
Why?
Yeah, so.
No, on an average 100 you will buy.
And you only win 2%.
Okay. On an 100 an average, but the person he is continuously buying. So he
But
bought
if
what
you
10, right?
If you bought 10 tickets, then his chances went from 2% to 18.3%. So how does it make sense? I know it mathematically it's correct. I know. I checked, but like my brain is
You
fighting.
understand this question, right?
My
So-
brain is fighting with the math.
No, no, your brain is fighting with the intuition.
Yeah.
Why? How does it work? On an average, 100 ticket is bought, the chance of winning the price is 2%. Okay, so if a person,
Every 100 tickets.
Yeah.
Win twice. So
Twice.
if the guy bought 100 tickets, he would have won twice.
twice,
But if you bought 10 tickets,
why it is 18%?
you would win once. No, you would.
18%.
Yeah, you would still win twice. Almost win. It's a weird problem.
Now, this is a good, like the good intuitive questions. How that? You understand his question, right?
Meaning,
You understand his question, right? So on an average, if a person buy 100 ticket, then the probability of winning is 2%.
so you win twice. Two winner tickets.
Two winner.
But if you buy 10, you still almost win 2 tickets.
Because without doing, I think,
Because
without
the person-
doing that, you would think that.
Okay, that one is two winner. That one is the on an average two winner. But now winner and probability of winning, these are two different things, I guess.
No, it's a, yeah. Intuitively, it should go down. It should be 0.2%.
For buying 10 tickets.
Yeah.
It's closer to buying 100, so you have more of a chance
How is it closer to buying 100?
instead of buying one.
No, no,
But
I'm,
10
no, no,
tickets.
I'm talking, so if his chances are 2% out of 100, I'll
See, listen, I have answer. If you buy one ticket, then your chance is 2%, right? And if you buy the second ticket, your chance will increase, right? If you buy the third ticket, your chance will increase, right? Do you understand? If you buy the fourth ticket, then your chance will be increased, right?
That's why.
Yes, but if his chance out of 100 tickets was only 2%,
No, that is,
if you buy
that is
99,
each person. So suppose 100% is in there, we'll go, each of us will have a one. So if you buy two, each of us buy one, then your chance is more higher than us. You are buying two.
oh, so it, okay, so one person bought all 10, but out of 100, it was talking about 100 like individual people when they're buying.
If you buy more tickets, you have a higher chance.
Yes, of course, but see, if the starting chance was out, so if you buy 100 tickets, you have.
No, listen, that is means what? One person's have a winning probability is 2% with the one ticket.
With one ticket.
One ticket,
Okay, then it makes sense. With one ticket.
one ticket,
Not 100,
not 100,
just one.
one ticket.
But if there's a two winner every 100 tickets, wouldn't that make one person a chance of 2% out of 100 tickets? If there is only two winners.
Now, that 2% is just if any person randomly buy one ticket, his chance of winning is 2%. Just 2%, one ticket. It is not like 100 tickets he bought, he won the 2%. That is just one ticket.
If you look at it that way, yes.
Yeah.
It's correct.
Yeah. Probability is a very big area, very big area. You cannot believe how big it is, okay? Okay, let me see. Okay, let us solve that one now. Using a six-sided die, Carling has rolled a 6 on each of the 4 successive tosses. What is the probability of Carling rolling a 6 on the next toss? It is still 1/6, right? Okay. Okay. So if I want to write it like different way, okay, a person throw 5 dice. Are you understanding? A person throw 5 dice. What is the probability that all 5 will be 6? Then what will be done?
Oh, that's big.
Now the problem is a person draw a dice successively. Each time he got 6, and then 5th time he draw. What is the probability it will be against 6? So each time he draw, that is independent of others. Okay, so that is a 1/6. But if the question is reverse, this gentleman throw 5 dice. What is the probability that all 5 are 6? It will be 1/6 times 6 times 6 times 6 times 6. You understand the question?
1 over 707,000.
Yeah. So, for example, if I want to write it in this question, yeah. So let me write like this way. Carlin throws 5 dice. What is the probability that all 6, all 5 throws 5 dice? What is the probability that all 5 dice will show 6? The answer is 1/6, 1/6, 1/6, 1/6, 1/6. There are 6 blue marble, 3 red, 5 yellow marbles in the back. What is the probability that selecting a blue or red marble on the first draw? Okay. Blue or red marble at the first draw. Yeah, 9/14. Clear, right? 9/14. Okay. So let us go to the another things. Let me see what is this one. Okay. In this case, okay, what is the prime number? When a number is said to be prime number? Yes. If the number cannot be divided except by itself. 3, 5, 7, 11, 13, 19, 17, these are all prime number. So in this case, we see only 7 are the prime number, right? So the question is, which number could be added to this spinner to make it more likely that the spinner will land on an odd number than a prime number? It has how many odd number currently? 7 and 15, right? These are the odd number. And 2 and 4 and 6 and 15, all of these are non-prime number. So we have to add a number so that more frequently it will be a odd number than a prime number. Do you understand?
Yeah.
So if I add here any number that is prime, then it will be a problem, right? Do you understand? If I add here 3, if I add here 11, then it will be problem because it will favor the prime number appearance if we spin. Right? But odd number, if someone asks me, then it should be 9. Right? If 9 is not, first of all, 9 is an odd number, but it is not a prime number. But if we add a 3, 3 is a odd number, but it is also prime number. Then if you spin, then chance of appearing prime number will be higher. What currently have compared to this, it will have higher. So vowel is just the A and E, right? So that means 6 over 2, right? 2 over 6, right? Okay, so solve this one. Max tested a coin to see whether it was a fair. The table shows the results of his coin toss experiment. So he tossed the coin 67 times. Okay, what is the relative frequency of the coin landing on the head? So that means 26 over 67. Okay, Grace rolled 2 dice. She then did something with the 2 numbers shown. Here is a sample space shown all possible outcomes. Die 1, die 2, and then so they are showing the difference of the column die with the row dice, right? So take a look at that. Yeah. So in the diagonal, if you go to the above to the diagonal, upper die, left die is subtracted from the upper die. If you go below the diagonal line, that means 0 line. So row die, column die is subtracted from the row die, right? Do you understand that thing? Yes and no. For example, how did 5 come in here? 6 minus 1 equal to 5. 6 minus 2 equal to 4. 6 minus 3 equal to 3. So this is the way he arranged these things. Okay. What did Grace do with the 2 numbers shown on the dice? Add them together, subtract the number on the dice 2 from number dice 1. Subtract the smaller number from the bigger number. Okay, this is the answer. Okay, let us do these things. Athar asked the student in his class whether they like math or whether they like sciences. He recorded his result in Venn diagram below. So math likes 9. 9 is just only math, and 7 like both 9 and 7 likes both science and math, and 6 like only science, and 7 does not like any of them. So how many students do not like science? 9 plus 7, right? So starter, main, and dessert. So starter has 2, main has 3, 2 and 3, 5, and then 2, 7. How many possible different combination of starter, main, and dessert are there? The question is little bit, how many possible different combination of starter? So that means you are talking about choosing one from there. So that means 2 choose 1 times 3 choose 1 times 2 choose 1, right? It is the basic principles of counting, right? So like here, take a look at that. There is a number 1 starter, main, and dessert. Starter has 1, 2, main has 1, 2, 3, and there is a 1, 2, right? So that means 2 times 3 times 2, 12, right? There are 18 girls and 12 boys in a class. 2/9 of the girls and 1/4 of the boys walk to school. One of the students who walks to school is chosen at random. Find the probability that the student is a boy. Okay, take 5 minutes and try to solve this. Not that difficult. There are 20 persons, and then 2/9 of the girls and 1/4 of the boys walk to school. One of the student who walks to school is chosen at random. Two-9 of the girls, so that means 4 girls and then 3 boys. So 7 persons walk to school. Okay. So 7 persons walk to school. Find the probability that the student is a boy. So 3 out of 7. Right? 3 out of 7. Rachel flips a biased coin. The probability that she gets 2 heads is 0.16. What is the probability that she gets 2 tails? So the probability that she gets 2 heads is 0.16, 0.16. Okay, so come in here. So he got head, 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 tail, tail, head, and tail, tail, right? This is the probability of 2 head equal to 0.16. Okay. So 2 head equal to 0.16, right? 2 head equal to 0.16. The probability that she gets 2 heads is 0.16. No, probability of each head is not equal to 0.6. So the probability that she gets 2 heads is 0.16. The probability that she gets 2 heads is 0.16. 0.84 equal to remaining. That means 1 head, 1 tail, and then 2 tail. But you are asked what is the probability she got 2 tails?
So in that case, we need to do square root.
Why square root of 16?
Then to find the probability of the
One
tail.
head.
Yeah, first we find one head and then the complementary will be one tail.
So that means you are saying since it is 116, it should be probability of head equal to 1 over 4 and probability of tail equal to 3 over 4. So probability of two head and it is independent. So it is 1 over 16. This is what you're saying? Yes. Why square root? Multiply if 0.6. So that means 0.4 times 0.4. 0.4 times 0.4 equal to 0.16.
So that's for the head, right? The tail, it would be complementary. So one head tail would be complementary of the one head, right? So it would be 0.6. And then we'll just multiply 0.6 by 0.6. And get the answer for the two heads, two tails.
Okay, so answer my question. Answer my questions. What is the, if this is the probability of the two head, 0.16, okay? So can I write probability of head which is equal to 0.4? 0.4 equal to 4 over 10. 4 over 10 equal to 2 over 5, right? Okay. So probability of head equal to 2 over 5. Probability of tail equal to 3 over 5. Yes. So that means 9 over 25. Is this the answer? 9 over 25 equal to what? Is this the answer? Okay. 0.36. Okay. So in this case, what is the probability of the orange? 1 minus 0.2 minus 0.15 minus 0.1 minus 0.3, right? So then you will get the orange. If I were to pick 60 jelly beans from the tub, how many orange jelly beans would I expect to pick? If I were to pick 60 jelly beans from the tub, how many jelly beans would I expect to pick? If I were to pick 60 jelly beans from the tub, how many orange jelly beans would I expect to pick? Yes, 60 times. Okay. So that is 50, 65, 75.25. Yeah. 60 times 0.25, which equal to 15. 15. Okay, let us do these things. Dexter runs a game. Dexter runs a game at a fair. To play the game, you must roll a dice and pick a card from a deck of cards. Dexter runs a game at a fair. To play the game, Dexter runs a game at a fair. To play the game, you must roll a dice and pick a card from a deck of cards. To win the game, you must roll an odd number and pick a picture card. The game can be represented by tree diagram below. Okay. So take a look at that. Dexter runs a game at a fair. To play the game, you must roll a dice and pick a card from a deck of cards. So I must roll a die and then I will pick a card. Okay. So this is what we want to do. To win the game, you must roll an odd number and pick a picture card. The game can be represented by the tree diagram below. Why? Because I need to roll a die and it should have odd number, right? So probability of rolling an odd number and even number is half and half, right? And then this odd and even, and after odd then we have to number and pick a picture card. Picture card, no picture card. Picture card, no picture card. So now Dexter charges player $1 to play and gives $3 to any winner. If 260 people play the game, how much profit would Dexter expect to make? So 260 plays. So you have to find the expected value by winning and losing both of them. You have to mix them together. Okay. You have to find the expectation so that winning and losing together could be made. Because take a look at that for the odd with no picture card. For this one, no picture card. This one has 9/3 and that one has uh, 4/3, right? 4/3. So the probability of winning odd is half, and then probability of winning picture card is like this. Okay. So let me connect the line. So this is for the half, for the odd, and half for the even, right? If someone got in there, he already lost, right? From there, picture, no picture. And then from there, picture, no picture. So no picture is 13. This is over 13. Four over 13. 9/13. So then we have to incorporate the money. Texter charges player $1 to play and gives $3 to any winner. Okay. So now $260 he receives 200. And then okay, first of all, probability of winning is half. Okay, multiplied by 4/13, and then multiplied by like this. This is the how many people won. Yeah. So this is equal to 2/13. So this is equal to, so 40 people win. So with 3, this is equal to 120. 120 is the, yeah. So that means 260 minus 120. I want to play this game.
$2.
260 minus 120. So 240. 140. 140. 140. If fair coin is tossed 3 times, work out the probability of getting 2 heads and 1 tail. So that is easy. Or we can do just the writing on the sample points and count in there. Okay. $200 people are asked about which athletics event they thought was the most exciting to watch. The results are shown in the table below. So it is a contingency table problem, right? So let me finish these things. 100-meter long jump and javelin. 100-meter long jump and javelin. And then male, female, 56, 32, 30, 29, 24, 29. So if you find the total in here, total equal to, here is 8, here is 8, here is 9, here is 5, here is 3, here is 5, here is 0, so 11, here is 0, 8, here is 0, 190, right? 200. So let me see. Female is 90. Oh, female is 90, yeah. So it should be 200. So now first problem is a person is chosen at random given that the person choose 100 meter, what is the probability that the person was female? Conditional, right? So probability, he choose 100 meter. And what is the probability that the person was a female? This is the answer. Female and 100 meter, 32 over 200, and 100 meter, 88 over 200. So the answer is 32 over 88. Problem number 2. Sam asked 50 people whether they like vegetable pizza or pepperoni pizza. 37 like vegetable pizza, 25 like both, and 3 likes neither. Okay, let me see. 50 people whether like. Okay, let me draw this one. One like this and another one like this. Vegetable pizza, BP vegetable pizza, and pepperoni pizza, PP. So the question was, he asked 50 people, 37 of them like vegetable pizza, 25 like both. 25 like both. So 37 minus 25 equal to 12. 12 like only vegetable pizza. So here is no pepperoni pizza, only pepperoni pizza is 0. And where is 10? 3 people like neither. These 3 people like neither. These 3 is in here, right? Okay, let me see. 50. Oh, okay. 50. If total people 50, then 50 people. So that means here, out of like 47, so 10, it should be 10. So if it is 25, so then 10 is in here. So only pepperoni, you would not find anyone. How? Yes. Yes. So 25. Oh, okay. Yeah. Yes. 10 people like is in there, but they did not mention these things because they mentioned the total people. So that is why you have to find it like that way. You understand, right? They mentioned the total people. As they mentioned total people, so that means this will come in there. So Sam picked one of the 50 people at random. Given that the person he chooses like pepperoni pizza, find the probability that they do not like vegetable pizza. So this is what he wants to find. Vegetable pizza complimentary. He liked the pepperoni pizza. Given that Sam picked one of the 50 people, given that the person he chooses like pepperoni pizza, find the probability that they do not like vegetable pizza. So now it should be probability of pepperoni and probability of non-vegetable and pepperoni. Okay. So vegetable pizza times pepperoni pizza, it is going to give you 10/50. And this is what pepperoni pizza, which is equal to, no, this is 25 plus 10, right? So this is 35/50. This is the answer. Okay, so this is the only pepperoni. You are saying 12, right? These 12 only vegetable. This is only vegetable. Okay, this plus that, this is entire vegetable. Among these vegetable, 25 of them like vegetable as well as pepperoni. This is only pepperoni. This is only pepperoni. This 10. People make a mistakes in this problem because they do not focus on the original 50. As I was doing, I was confused like whether the 10 should be in there. Then I said that, well, they have mentioned 50 people, right? So that means you have to make the Venn diagram in such a way that 100 frequency within this Venn diagram should represent all 100% frequency. You are okay? Clear now? There are 12 marbles in a bag. There are n red marbles and the rest are blue marbles. Nico takes 2 marbles from the bag. Write an expression involving n for the probability that Nico takes 1 red marble and 1 blue marble. Okay. Okay, there are 12 marbles in a bag. There are n red marbles and rest are blue marbles. So there are 12 marbles and red and then rest are blue. So 12 minus n equal to blue. Okay. 12 minus n equal to blue. N red, 12 minus n equal to blue. And then what they are asking, Nico takes 2 marble from the bag. So 12 choose 2 denominator. Write an expression involving n for the probability that Nico takes 1 red marble and 1 blue marble. 1 red marble and 1 blue marble, and choose 1, and 12 minus n choose 1. Right? You get it? Okay, so let me do another type of problem. I think we did it. We did it. Okay, let us do one problem with the multiple table, joint discrete table. Use this one. Okay, so see, x and y, these are two random variable. X can take value 1, 2, 3. y can take value 1, 2, 3. And this is the probability 0.2, 0.32. 0.32 is the probability that x equal to 1 and y equal to 1. 0.03 is the probability that x equal to 1 and y equal to 2. 0.27 is the probability that x equal to 3 and y equal to 3. These are the 9 probabilities. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the 9 probabilities. If you add all of these, this is the probability that x equal to 1. This is the probability that x equal to 2. This is the probability that x equal to 3. If you add them up, this is the probability that x equal to 1. This is the probability that x equal to 2. This is the probability of x equal to 3. Okay. Now from this is the marginal distribution of x. This is the marginal distribution of y. When you sum over the y values, so this is the y values. If you sum over the y values keeping x equal to fixed, then this is the marginal distribution you will get for that variable. If you keep y fixed and sum over the x, then you will get the marginal distribution of y. You are fixing y equal to 1, you are summing over x equal to 1, x equal to 2, x equal to 3, then you are getting the distribution of y, which is known as the marginal distribution. So from there now, if you are asked to find the mean of x, this is the way you have to find the mean of x. 1 times 0.36, which is this, 2 times 0.32, 2 times 0.32, and 3 times 0.32. This is the average expected value or mathematical expectation of x. Okay. Now, how to find the mathematical expectation of y? So, y value 1 times this, 2 times this, 3 times this will give you this, the mathematical expectations. How can I find the joint expectation? X, y time like this. You will take x equal to 1, y equal to 1, x equal to 1, y equal to 2, x equal to 1, y equal to 3, x equal to 2, y equal to 1, x equal to 2, y equal to 2, x equal to 2, y equal to 3, like this way. This is joint expectations. Okay. You remember when I solve this problem, I solve what? I gave you this type of problem. What type of problem I give? I give a problem, then I ask you find expected value of x, and then find expected value of y, then find variance of x, which you found by applying this, and variance of y, then I also showed you how to find the covariance of x comma y, expected value of xy minus expected value of x times expected value of y. Okay. So these three things I have shown you by doing the computation. What is mine that? You remember these things? This problem I solved and I have shown you, see, all of these things. Are you seeing the covariance? I have computed it in here. And in order to compute the covariance, you have to like this. And then I have shown you the difference. How can you find the average when data is given? How can you find the average when the random variable together with their associated probability is given? That is known as the mathematical expectation or expected value. Mean and variance you can find. Let me remind you, if I ask you find the mean and variance, please don't fall from the sky, okay? So take a look at that. Mean from the data can be obtained by using this format. Okay? This is known as the mean or average. And expected value you can only compute when you are given x equal to 1, 2, 3, and then probability of x equal to given 0.3, 0.4, 0.3, right? In that case, so random variable x is appearing with probability 30%. Value of the random variable 2 is appearing with probability 40%. Then you can find this. Similarly, in order to find the covariance, you need to have a joint distribution of x and y. Here 0, 1, 2, here 0, 1. In that case, the probabilities or frequency will be given from this probability. If frequency given, then frequency distribution, joint frequency distribution, you can convert it to the joint probability. Remember the player, non-player, and minor and adult, that was in the frequency table, but I converted it to the joint probability table. Okay. And after converting then you can compute mean, variance, covariance, and everything. So my experiences is telling me, if I ask my student compute average, variance, but the data is given in the format of a probability distribution, I still see student just multiply these values. They find in 1 plus 2 plus 3. So that is equal to 6. 6 divided by 3 equal to 2. But that is not the mean, right? Do you understand what I said? That is not the mean. Okay. So with that being said, let me see what else I can cover. Yeah, I think most of the part I covered for this one. The next one would be about probability distribution. So from week after next week, I will start discussing probability distributions like this one: uniform, binomial, Poisson, negative binomial, geometric, uniform binomial, Poisson, negative binomial, geometric, and normal distribution, and finally sampling distributions. These are the things I will cover in maybe 3 weeks, and then I will go for the test of hypothesis confidence interval. Okay, we have plenty of time. Okay, the way I am covering slowly the materials, trying to cover all of the things. Remember, whatever so far you have learned, these are all foundational things and explanation. So next class, the probability distribution. Some of the problems you cannot compute without knowing this distribution, without knowing this mathematical formula. The probability you can never compute. So these are the probability models that I'm going to discuss week after next week. Next week will be the class in online. I will maintain the office hour, no face-to-face. You do not need to come. If you have any problem of your exam, just let me know. Okay? And I in the 1 to 4:45, I will be in this evening, or you can email me. I will respond to your email, so we can meet in online. Okay? Okay, I'm going to stop in here. We have 5 more minutes, but if you have a question, you can ask me. Otherwise, I'm going to stop in here.